Hello, Geometry Cherubs. Today we're going to talk about how to find the area of kites and rhombuses. All right. So first of all, what is a rhombus? We studied the rhombus in Chapter 6, Section 6.4. A rhombus is a special case parallelogram with all four congruent sides. What is a kite? A kite is a different kind of quadrilateral that has two pair of consecutive congruent sides. And an important thing to know about both the rhombus and the kite is that they have perpendicular diagonals. And that's something that's going to be crucial to solving these problems today. And you have to be able to see where the whole diagonals are because we're going to need the diagonals for the area formulas for both of these shapes. These shapes have the exact same formula, although they have some differences in terms of their diagonals. In the rhombus is a type of parallelogram, so the diagonals will bisect each other, but that does not happen in the kite. In the kite, you've got a power diagonal that goes in between these two congruent sides and in between these two congruent sides. That's the power diagonal. And she bisects everything in her path. She bisects this angle, she bisects this angle, and she bisects the other diagonal. And then you've got this other like starfish diagonal. And in the kite, this diagonal that goes from this in between these two sides that are not the same to in between these, so like in between the elbows, this diagonal does not bisect anything. It gets bisected, but it doesn't do any bisecting. This angle does not get bisected. This angle does not get bisected. And this diagonal does not get bisected. So you've got to keep those things straight. Those are the theorems that we have to remember as we delve into the area formulas of these two shapes. So let's start with the kite. With a kite, we see that this diagonal is 5 plus 2 is 7. This diagonal is 3 plus 3 is 6. And so we can plug it into the formula. Half diagonal 1 times diagonal 2, and we've got our area. Now here we have another kite. The key to the kite, one of the keys is remembering that the diagonals are perpendicular. And so we can draw a picture drawing in the perpendicular here. And then we have ourselves a 45, 45, 90 triangle here. And because of that, we know that if this is 9 root 2, then going backwards, the legs would be 9. Now we know that this is the diagonal that gets bisected. So if that's 9, that's 9. But this is the diagonal that does not get bisected. It does the bisecting. So we have to figure out if that's 9, this is 6, we add them together to get the other diagonal is 15. So we've got 9 plus 9 for diagonal 1 and 9 plus 6 for diagonal 2. And then area is half diagonal times diagonal. All right, so now, how can we do this one? How can we find the area of the rhombus? We have to remember the rhombus, the diagonals are perpendicular. And if that's 30, we have to also remember that the special theorem about the rhombus says that in a rhombus, the diagonals bisect the corner angles. So, and in all parallelograms, the opposite angles start out the same. So if they start out the same, their halves will be the same. So all four of these will all be 30, 30, 30, and 30. And we know the other theorem about the rhombus is that the diagonals are perpendicular. So if that's 90, that's 30, that's 60. And that means all of these are 60. So we have 4 little 30, 60, 90 triangles for this particular problem. We also know that because it's a rhombus and a rhombus is a parallelogram, all diagonals bisect each other. So if that's 8, we know this is going to be 8. And so therefore we know this entire diagonal is 16, but we don't know what this diagonal is yet. And so we have to use our knowledge of 30, 60, 90 triangles. And we look in this little triangle and we say, well, what was 8? Well, 8 is across from the 60-degree angle, which means it's the long leg. So to go backwards from long leg backwards to short leg, I have to divide by root 3. And I get this number if I rationalize the denominator. You could also get a decimal, that's fine. Then if this part is 8 root 3 over 3, we would have to double it to get the whole diagonal. And if we double it, we get this value. Once we know both diagonals, we can plug it into our formula to get our final result. And you could leave it in radical form or get a decimal approximation. So pause the video, practice finding the area, and then press play for the solution. It's a rhombus, so we know that all these 4 angles will be 60, and all 4 of these angles will be 30 because the diagonals are perpendicular. We know that it's a parallelogram, so the diagonals bisect each other. So if that's 4, that's 4. So this diagonal is 8. But we've got to figure out what is this length. And so we use our 30, 60, 90 triangles. And we say that if this side is 4 and it's across from the 30, it's the short leg, across from the 60 would be 4 root 3. And then we double it to get the whole diagonal, 8 root 3. Once we have both our diagonals, we can put it into our formula, area equals half diagonal times diagonal, to get our area. Pause, find the area, and then press play for the solution. The key to this problem is that we know that if it's a rhombus, all these angles are the same, and these are perpendicular, so this must be 45. So all of a sudden we realize that this rhombus is a square, and we know squares are rectangles, and rectangles have congruent diagonals. So the minute we see that both the diagonals are 6 because it's a square, we can easily plug it in, half, 6 times 6. So now you're ready to complete the rhombus and kite problems in the packet, and also the 10 2B Math Excel assignment as well. As always, let me know if you need any help.